Hello everyone, welcome back to the Cairo streams. In this particular stream, we are going to continue from the last point where we left. In this stream, we are going to see the advanced types in Cairo, the structs, how we can use structs to create custom types, enums and pattern matching, and how to use multiple modules to manage your code better. And then there is the concept of traits and generic functions that we'll see. So yeah, let's get started. Okay. Okay, so just give me a sec. Okay, let's just first run our you know project. I just want to make sure that it runs fine. Okay, so I guess I have to write the command grab build scarf build and scarf Cairo run happen available gas is equals to 20,000. Let me write this command in readme as well, so you don't have to you know take this again and again. Oh, okay. Useful command, single command to run, single command to build and execute. Okay, scarf build and scarf Cairo run. Okay. Okay, now let's go to concepts. Using structs to structure related data. Using structs to structure related data, a struct or structure is a custom data type that lets you package together and name multiple related values that make up a meaningful group. If you are familiar with an object-oriented language, a struct is like objects data attributes. In this chapter, we will compare and contrast tuples with structs to build on what you already know and demonstrate when structs are a better way to group data. We will demonstrate how to define and instantiate structs. We will discuss how to define associated functions, especially the kind of associated functions called methods, to especially behavior associated to specify behavior associated with a struct type. Structs and enums are the building blocks for creating new types in your program's domain to take full advantage of Cairo's compile time type check. So basically, structs is sort of, object, with, multiple types of fields and like, like a person object, right? Like you can have a name, date of birth, and email and age, these different sort of things. So let's just see. Okay. Defining and instantiating structs. Structs are similar to tuples discussed in the data type section. Okay, and just give me a sec. Okay, structs are similar to tuple defined and discussed into the data type sections. In that both hold multiple related values. Like tuple, the pieces of a struct can be different types. Unlike with tuples, in a struct you will name each piece of data, so it's clear what the values mean. Adding these names means that structs are more flexible than tuples. You don't have to rely on the order of the data to specify or access the value of an instance. To define an struct, enter the keyword struct and name the entire struct. A struct's name and struct name should describe the significance of the pieces of data being grouped together. And then inside curly braces, we define the names and type of the pieces of data, which we call fields. Okay, so let's define this struct, that that we are seeing. So just give me a sec. Okay, let me open this. Okay, so we can maybe, okay, so let me create a new module 06 structs dot Cairo. And I'll close all file, close others. 06 struct. Okay, so I'll do struct user and active bool username felt 252. Right now, like currently Cairo doesn't support long strings. So if you have to use the strings, you can only store short strings in the felt type, which is, I guess, string with less than 31 characters, I guess. So you can use this email felt 252, which I guess works fine for our case. Example, sign in count, yeah, u64. Okay. Okay, we can directly, I guess, we can directly use, let me just define the mod underscore 06 underscore structs. Okay, use maybe. Okay, okay. Now if we want to define the user, let's comment these. Let user1 wish to user active true, username system, email system @gmail.com, and sign in count 0. Okay, now if I try to, let's say, do this user1 dot print, I don't think it will work because we need to annotate this struct with the debug trait. But anyway, let's try this. Yeah, method print could not be found, right? So maybe we have to use debug print rate. Okay, and then we have to do derive print rate. Now maybe it might work. Okay, method print does not found on the debug. Maybe we debug. Yeah, so we are not able to print this. Okay, no worries, we'll figure this out later. To get a specific okay, okay, let me search how to print a struct, how to print a struct value of type struct in Cairo programming language. Cairo I don't think this will be able to, we'll be able to see this. Struct person. Uh-huh. No. Let me just ask this question in, is there a way result, is there a way we can print value type struct type? Maybe by driving driving rate construct. Okay. Mm-hmm. Mm. Okay, so we will come to this thing later, but right now we see that we are able to, create a struct at least. So, and we should be able to mutate the struct as well. User one dot email. Mm, mm. Define a struct. After we have defined it, we create an instance of that struct by specifying concrete values for each of the fields. We create an instance by stating the name of the struct and then add curly brackets containing key value pairs. Yeah, to get a specific value. Now let's change the user one dot email is equals to, let's say, sat at the rate uh, gmail.com. Now let user email is equals to user one dot email. mm, User email dot print. Yeah, obviously we can like, print this way, user one user email dot print. Hmm. Ah, okay. Use debug print rate. Maybe then, yeah, semicolons. Okay, the main panicked. Okay. Add user underscore. Mm-hmm. Mm, okay. So why it panicked? Uh, is if we remove this user one dot email, does this work? Hmm. So this obviously, ah, okay. Why it is panicking? Okay, I get it now. So we have to basically we have defined this struct as mutable, so we should be able to derive the drop rate We should also do annotated with copy trait. We have to do that to basically drop this value, once it is out of scope. Hmm. I think now this should work. Hmm. Now let's see if it works. Hmm. Now if we print it, then we will try debug. So if it works debug, then the behavior is similar to Rust as well. No. Hmm. So this one doesn't work. Okay. Note that the entire instance must be mutable. Cairo doesn't allow us to mark only certain fields as mutable. As with any expression, we can construct a new instance of the struct as the last expression. That is true. It makes sense to name the function parameters with the same name. So the shorthand syntax also works, which is again the same as the Rust behavior. Okay, now the let's come to the example program using the struct. What it is building. Mm, the example is same as a Rust book. An example program using Rust to understand when we might want to use structs. To understand when we might want to use struct, let's write a program that calculates the area of a rectangle. We will start by using single variables and then we factor the program until we are using structs instead. Okay. Let's make a new project with a script called rectangle that will take the width and height of a rectangle as specified in pixels and calculate the area of the rectangle. Listing 5.65, so is a short program. Okay. This code succeeds in figuring out the area of the rectangle by calling the area function. Then it is with tuples. Okay, structs. Here we have defined a struct named it rectangle. Inside the curly braces we defined the fields as width and height, both of which have type U64. Then on the main we created a particular instance of rectangle and okay. Over area, here we have defined a struct and named it rectangle. Inside the curly brackets we define the fields as width and height, both of which have type U64. Then in main we created a particular instance of rectangle that has a width of 30 and a height of 10. Our area function is now defined with one parameter, which we have named rectangle, which is of the type rectangle struct. We can then access the fields of the instance with dot notation, and it gives descriptive names to the values rather than using tuple index values of 0 and 1. Okay, so let's build this example, example program. So you have to go this way. So let's build this example program. Struct rectangle. U64. U64. Okay. Okay. Fn area rectangle and it returns U64. Okay. Then we do rect dot width, rect dot height. If we don't put a semicolon, this is by default the return value. It's the expression. Now let's build the function. Let's say area example, right? Let rect1 equals to rectangle width 10, height let's say 25. Okay, so we should get the area rectangle rect1. Let's say rect1 area dot print area dot print. Okay, now let's bring this area example. So we got the area which is 0xFA, and if you convert this, so there must be a way to convert away nodes. Let's try way to convert hexadecimal to decimal in Node.js. A to B or something. %. Yeah, maybe we can do something like parse int 0xFA16. No way. Rect1 area should be 250, right? Yeah, area dot width. Okay, maybe it's related to, yeah. See, we can get this. Okay, now let's see. Adding useful functionality with trait. It would be useful to be able to print an instance of rectangle while we are debugging our program and see the values for all of its fields, right? Yeah, okay. The print trait is implemented for many data types, but not for the rectangle. We can fix this by implementing the print trait. Oh, nice. So that is the way we will print. Implement rectangle print trait. The name can be anything. Rectangle print implementation. But that's nice. This is something that I needed. And yes. Okay. Let's implement this thing. Implement rectangle print implement of print trait rectangle. Okay, fn print self rectangle self dot width dot print. Maybe we can do something like this. Mm, Maybe self dot width height dot print. Maybe I'll do rectangle width and height. Let's see if this is length is more than 31. Will it 31 6 9 uh 14 14 and 418. No, it will be, I guess, perfectly fine. And we can use let's say rect1 dot print. hmm. Hmm. Okay, so that means we are, let's print this before we can have another way of not moving things. hmm. uh-huh. Derive draw and copy. Let's not implement the copy, only draw. Select one. Okay, this is the 10 or 25. Right. Now my question is how we can do this thing as well. Like, I'm not implementing the copy trait, so if I do this, will it work? It will not work because it is working. No, I don't implement the copy trait. Now it will be moved. Right. Now what I think is I can do at the rate rectangle, that is the snapshot at rectangle. Now it, yeah, what do you say? Hmm. Star. Now it will work. Yeah, now it worked. Rectangle width and height, rectangle area. Star, this is basically now I'm passing the snapshot of the value. Okay, so this is good. Now we have to basically, oh, I now I think we can start with the other concepts. Method syntax. Let's see the method syntax there. What is the method syntax is saying? Methods are similar to functions. Okay. Methods are similar to functions. We declare them with the fn keyword and a name. Okay. They can have a parameters and a return value, and they contain some code that's run when the method is called from somewhere else. Hmm. Methods are similar to functions. We declare them with the fn keyword and a name. They can have parameters and a return value, and they contain some code that's run when the method is called from somewhere else. Unlike functions, methods are defined within the context of a type, and their first parameter is always self. Yeah, that's important. Which represent the instance of the type. Now, which represent the instance of the type the method is being called on. For those familiar with Rust, Cairo's approach might be confusing. A methods cannot be defined directly on types. Oh, uh, instead you must define a trait and an implementation associated with the type for which the method is intended. Hmm. Okay, let's read it out loud again. Actually, so methods are similar to functions. Okay, we declare them with the fn keyword and the name. They can have a parameter, return value, and they contain some code that's run when the method is called from somewhere else. Okay. Unlike functions, methods are defined within the context of a type, and their first parameter is always self, which represents the instance of the type the method is being called on. For those familiar with Rust, Cairo's approach might be confusing, as methods cannot be defined directly on types. Instead, you must define a trait and an implementation associated with the type for which the method is intended. Defining methods. Let's change the area function that has a rectangle instance as a parameter, and instead make an area method defined on the rectangle trait. So we have a rectangle. We have derived copy trait and drop trait. That means value, when we pass the value as a parameter, it will be copied. Okay. And the drop trait, that when the value is out of scope, it will be dropped. Use, debug, print trait, implement trait, rectangle trait, chain area, self. Okay, snapshot, implement rectangle implementation of rectangle trait. Okay, now where, yeah, okay, so this is how we are doing basically with the rectangle. That's also nice. That's also very nice actually. To define a function within the context of rectangle, we start by defining a trait block with the signature of the method that we want to implement. Okay, traits are not linked to a specific type. Only the self parameter of the method defines which type it can be used with. Okay. Uh, okay. Then we define an implementation block for rectangle trait. This defines the behavior of the methods implemented. Okay. Everything within this implementation block will be associated with the type of the self parameter of the method called. Okay, so while it is technically possible to define methods for multiple types within the same implementation block, it is not a recommended practice as it can lead to confusion. We recommend that the type of the self parameter stays consistent within the same implementation block. Then we move the area function within the implementation curly block and change the first change the change the within the then we move the area function in curly bracket and change the first and in this case only parameter to be set in the signature in the main. When we call the area function and pi rectangle one as an argument, we can instead we can instead use the methods instead to call the rectangle. This method enters goes after an instance. We add a dot followed by methods must have a parameter named slab of the body. They will be applied for their first parameter. Note that we have used the snapshot operator in front of the rectangle type in the You indicate this method takes an immutable snapshot of the rectangle instance, which is automatically created by the compiler instance to the method. Methods then take ownership of the self, use self with snapshot as we have done here, or use immutables. Okay. When we choose for the same reason we in the function version. We don't want to take ownership. We just want to read the data in the block. So struct not write it. If we wanted to change the instance, we would have called the method on this particular using rep self. Giving a method that takes ownership of the this technique will be used when the method transforms self into something else and you want to prevent the caller from using the original instance after the transformation. Observe the use of the dsnap operator within the area method when accessing a struct member. This is necessary because struct is passed as a snapshot and all of its fields values are of type snapshot, requiring them to be desnapped in order to manipulate them. Mm, the main reason for using methods instead of function is for the organization and code clarity. We have put all the things we can do with an instance of a type in one combination of create and implementation block, right? Mm, create and implementation blocks. Rather than making future users of our code search for capabilities of rectangles in various places in the library we provide. However, we can define multiple combinations of traits and implementation blocks for the same type at a different places, which can be useful for a more granular code organization. For example, you could implement the add trait for your type, type in one implementation of trait. Note we choose to give the method the same name as the struct field. Hmm. Maybe actually, okay. It's changing to make the with method return true. The value is okay. You need a in the purpose. Cairo knows. I mean, okay. Methods with more parameters. Hmm. Can hold, right? Right. Okay. We methods with more parameters. Let's practice using methods when implementing a second method on the rectangle struct. This time we want an instance of the rectangle to take another instance of rectangle and can return true if the second rectangle can fit completely within self. Otherwise, it should return false. That is, once we have defined the can hold method, we want to be able to write the function. Okay. The expected output would someone like the following. Okay. Hmm. Okay. So basically, let's try to write the example of this thing, and then we will come back. Mm. print, I think. Like, you know, debug. J32. Okay. So, okay, let's see the code in action. So we have this rectangle trait. Rectangle is already there. We are not going to implement right now. Okay, so rectangle trait. So let's first define the rectangle trait rectangle trait. Okay, and we are going to define the area method signature there, self, which is a snapshot of rectangle. It is going to return u64. We just need to define the signature. Then we define the implement rectangle implementation of rectangle trait. Okay, fn area self at rectangle u64, and it will return the self dot width, self dot height. Now area we can do this way, or maybe we can do rect1 dot area. I guess that should also work. Rect1 dot area. Wait a minute. Implement. Oh, we need to return this. Yeah. Rect1 area, we got the area. Okay, and print. Why we have basically done this? So rect1 we have moved. So print takes, why it is taking the, yeah, let's just use the, let's desnap this. Variable Okay, rect1 dot print. So you are not moving the rectangle there. What is this parameter implementation? Incompatible with print executed. Okay, so that means this function is only going to take directly the values. Okay, maybe if I implement the copy trait, I won't have this issue. Then it will not be moved. Okay, that's nice. Now we can make the another function where we can check that can hold sort of thing. So let's see. Okay, rectangle trait append can hold self is rectangle snapshot at rectangle, and other is second rectangle is also rectangle, and it is going to return boolean. Okay, and we can do append can hold self at rectangle, comma other rectangle, second rectangle. It's also at rectangle. Okay, now we can do return. It will obviously star self dot width greater than star second rectangle dot width, and star self dot height greater than star second rectangle dot height. Okay, so it will give us the area. So let's make two rectangles. Let two first two rectangle. So its width is 9 and height is 30. Okay, let rect3 rectangle, width is 12, height is 20. Okay, let rect4 rectangle, width is 5, height is 24 and 9. Let's see. Okay, and let rect5. We don't need rect5. Okay, so let's do rect1 dot can hold at rect2 dot print this formatting thing doesn't work. I don't know why. Rect3 rect4. Okay, so it should print false false true. Okay, false, false, true. uh, we can also write our test cases. This is, I guess, the good time to write test cases. Test CFG, use super test can hold FN, can hold smaller. So we'll do something like, something like this, and we'll do, let's copy this one, and obviously we can do let result equals to rect1 dot can hold and rect2 and assert result cannot hold, fail to hold smaller rectangle. Okay, इसका build and Cairo test, maybe type not found. Okay, I mean, it should be able to, let's just see, maybe I am missing something. Testing Cairo programs, I mean, it was pretty straightforward the way I knew it, but maybe I'm missing something. lib.cairo, it works. Okay, Cairo. Okay, test. Inside a module. Okay, it uses CFG test. More tests. Okay, then CFG test. Maybe. We need to bring the rectangle. Wait. Fact 4. Okay, finally our test case pass. Okay guys, I mean, that's quite enough. Let's take a 5-10 minutes break, then we'll start with the enums. See you guys. Welcome back, guys. Let's continue with our generic types. So we have done with this method syntax thing. Let's see if there is anything else. Methods with more parameters. We have seen rectangle traits. Okay. We can have a square. Okay. Hmm. So there is this accessing implementations methods, all functions defined with a thread and implementation blocks can be directly addressed using colon operator from the functions in the threads. Methods are often used for constructors that will return a new instance of the struct. We have one called new, but new is not a special name and is not built into the language. For example, we can choose to provide an associate. Okay, so we can have a multiple. Okay, rectangle clamp. Okay, rectangle calci can hold. Yeah, we can have multiple implementation blocks, obviously. But let's just try to get the square thing out of the way. So we can, build the square thing. So we don't, yeah, so we can just do in this fn square, which will take, let's say, side u64 and it will return a rectangle. Okay, so if we can do this like fn square side u64, it will return a rectangle and we just return a rectangle with the width of side, height, side. Okay, we don't need a semicolon, just we are directly returning. So let's just do let square equals to sq square sq1 equals to, okay, rectangle square 10, and we can print sq1 dot width dot print sq1 dot height dot print. So we should get the and sq1 dot area dot print also. We will have to do this. What it is gives telling us that invalid path. Okay, why it is giving us the fn square size. Okay, so we'll have to, instead of doing this, we'll have to do rectangle trait, because it is available on the trait. So we get the side 10 and 10, and then this is the 100. Okay, so this is the way we will do it. This is a bit different from the Rust. In Rust, we can directly have methods on the type, and in Cairo, I see that we have to define methods on the trait. But I guess it's more or less same. Let's commit all of these changes. So struct examples. Okay, now let's come to the enums and pattern matching. Okay. Hmm. Enum, short for enumerations, are a way to define a custom data type that consists of a fixed set of named values called variants. Okay, enums are useful for representing a collection of related values where each value is distinct and has a special meaning. Special meaning. Enums is sort of like one of these possible values, right? Like this example of direction, where a direction can have one of those four values: north, east, south, and west. In this example, we have defined an enum called direction with four variants: north, east, south, and west. The naming convention is to use Pascal case for enum variants. Each variant represents a distinct value of the direction type. In this particular example, variants don't have any associated value. Okay, it's easy to write code that acts differently depend upon the variants of any code. In this example, do not okay. Enums combined with the custom type. Okay, and enums can have the associated value. Okay, in this example, quite doesn't have any associated value. Echo is a single field element. Tuple of 2, and move is a tuple of 2. You 128 values. You could even use a struct or another enum you defined inside one of your enum. Okay, trait, we can define trait, and okay, so we can define trait. Okay, so this is the enum. The option enum is a standard Cairo enum that represents the construct of an optional value. It has two variants, some and which are of type T, none, which represents the what I would say unit tuple type, indicates that. Okay, the option enum is helpful because it allows you to explicitly represent the possibility of a value being absent and making your code more expressive and easier to reason. Using option can also help prevent bugs, uninitialized or unexpected null values. Okay, to give you an example, here's a function which returns the index of first element and when given a value and none. Okay, array of, okay, so we are going to first run this example and then we will play with this array example, right? Find value recursive, array value index greater than, okay, find value, right? So let's try to run this particular example. So let's go to the enum. Okay, so let's go to code. Let's create a new module. Underscore 07 underscore enums.cairo. So we'll do enum direction north, east, west, south. Okay, and we'll drive the drop right there. Okay, now we'll define a trait processing. And we'll define the method signature, which will take self of type message. Okay, now implement process L of processing. Let's implement the trait fn process. Right now this trait is not attached to any type, but now we are attaching it to message type for this particular method process. Okay, fn process match self. We'll talk about the match quit. Dot print. These are the arms of the match thing. Echo value. Okay. Okay. So I guess we have to find the wrong enum for this. So we define one more enum message. Enum message. Quit echo, which is of value of type L252, and move, which is a tuple of type usize, which is again u1 u32, and drive drop. Okay, and match self echo value dot print. Okay, and message move x comma y. Then we print like moving print x dot print y dot print. Okay, and this is what we have done. Let's write this message example. Let msg type message. If we don't define the type, quit. Okay, msg dot process. I'm just trying to see if Cairo can Cairo can infer the type. Let's move this actually to use. Let's first define the mod underscore 07 underscore enums. Use underscore 07 enums message comma process implementation processing. Okay, let's comment all of this. And okay, and message example. We don't need to take this then, because we are already doing this in message example. In message example, all of this is already, accessible. Message example. Let's see. Hmm. Method print not found. Okay. Hmm. Maybe. Okay, then we cannot print this. Okay. Right. Use debug print rate. Okay, now it should work. We are missing one colon and wait a minute. Okay, let's do move echo 10. Should print value 10. Okay, and move 10 20. It is printing 10 and 20. Okay, so this works perfectly fine. Now we'll do this second thing. Okay, find value recursive, and so basically what we are going to do is we are going to iterate an array. Using the find value recursive. Hmm. Zero match result. Okay, so let's make this method find value recursive. Fn find value recursive. Okay, what it is doing is ultimately it is taking a snapshot of array. It's a snapshot of array of type field elements. Okay, value to find and index size. Index is basically the initial index, and it will return the index at which the value is find. Option usize. Okay. Okay. If index is greater than or equals to array of length, array length method is only accessible on snapshot, so we need to pass the snapshot function none, right? if dot add index equals to value, return some index. Otherwise find value recursive array value index plus 1. So that is how. Now let's example. Now let mix the array. Let mute err equals to reiterate new err dot append 1 err dot append 3 err dot append 5, and let's copy these 11 33 57. Okay, let value to find equals to 33, so it should be at 0 1 2 3 index 4, right? Let result equals to find value recursive. Okay, and arr value to find and 0. Okay, match result. Option some index if index equals to 4, it worked. Print not found dot print. Okay, find value recursive example. Okay, find value recursive example. Let's see if okay, unexpected return type. So in find value recursive, okay, option of use size, okay, we should not use the semicolon. That's a very common mistake people do. So we see it worked, and now we do value 330. Let's say we should get the not found printed, so we get the not found. Okay, we can also use the point value iterative, which is again yeah, we can do this similarly for the find value iterative, where we just iterate through the loop. Okay, so Now let's go to the match control flow. The match control flow is again very similar. Uh, Cairo has an extremely powerful control flow construct called match that allows you to compare a value against a series of patterns and then execute case based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. Hmm. Okay, so Cairo has an extremely powerful control flow construct called match that allows you to compare a value against a series of patterns and then execute code based on which pattern matches. Patterns can be made up of literal values, variable names, wildcards, and many other things. The power of match comes from the expressiveness of the patterns and the fact that the compiler confirms that all possible cases are handled. Think of a match expression as being like a coin sorting machine. Coin slides down a track with a variously sized fold along with it, and each coin files through the first hole it encounters. I've read this example, done this example before in Rust book, so I'm not going to do that. Patterns that binds to values, and I've done the same example there, matching with options. Seen this example, matches are exhaustive. Using enums, you can also take, you know, underscore, which is an exhaustive placeholder. So, seen this. Managing Cairo projects with packages, crates, and modules. I have read that already. We are using already modules. We are already using modules, so I don't think so. We need to, you know, use there is anything different there, and creating idiomatic paths, providing using as keyword. Okay, separating modules into different files. This is like very basic thing. Now let's come to the generic types and traits. Every programming language has tools for effectively handling the duplication of concepts in Cairo. Some such tool is generics, abstract standards for concrete types or other properties. We can express the behavior of generics or how they can relate to other generics without knowing what will be in their place when compiling and running the code. Functions, structs, enums, and traits can incorporate generic types as part of their definition instead of concrete values. Generics allows us to replace specific types with a placeholder that represent multiple types to remove code duplication. Generics allows you to replace okay, for each concrete type that replaces generic type. Okay, I guess the behavior it's the same, and I don't see a concept of lifetimes there, but anyway, we are going to do these examples tomorrow, or maybe later today in this stream. For now, I guess, guys, that's it. I will be pushing the code, so yeah, enums example, and I'll